Hello, this is Miss Igo. Welcome to my classroom. Today we're going to be talking about the slope-intercept equation of a line. The slope-intercept form of the equation of a line is y equals mx plus b. In this equation, m represents the slope of the line and b represents the y-intercept, or where our line crosses the y-axis. Knowing this equation of a line will allow us to find the slope and the y-intercept of an equation. If our equation is not in this form, we need to rearrange it to get it into this form, and then we can pull out the slope and the y-intercept of the equation. Here we have an equation that is already in slope-intercept form. So, in order to find the slope of this equation, we just look for the coefficient of our x term, and that will give us m, which is our slope. So in this case, our slope is 2 over 3. The y-intercept is represented by the b in the equation. So in this equation, our y-intercept is a positive 5. Here's another equation that is already in slope-intercept form. In this equation, our slope, or our m, would be 4. Remember, it's the coefficient of our x term. Our b, or our y-intercept, is going to be negative 1. Remember, slope-intercept form is y equals mx plus b. So if there's a negative sign here, that's going to go with the y-intercept. So our y-intercept is negative 1. Okay, in this equation, we have y is equal to negative 1/2 x. So the slope in this line is negative 1/2 because that's the coefficient of our x term. And our y-intercept, we don't have a plus or minus anything, so we could think of that as being a plus 0, and that means that our y-intercept would be 0. This equation is not in slope-intercept form, but we can easily rearrange it to get it into slope-intercept form in order to find the slope and the y-intercept. So to get it into slope-intercept form, we need to solve for y, and the first step in doing that would be by subtracting 6x from both sides of the equation. All right, once I subtract 6x, I get 3y equals, I'm going to put the negative 6x in front of the negative 9 because remember, our goal is to get it into y equals mx plus b. So minus 6x minus 9. And then y is not quite by itself yet, so to get it by itself, we need to divide by 3. And when we divide, we need to divide everything in the equation by the same number. So we're dividing by 3. And that gives me y is equal to negative 2x minus 3. Now it's in slope-intercept form, so we can pull out our slope and our y-intercept. The slope of this equation would be negative 2, and our y-intercept is negative 3. Now that we know how to get the slope and the y-intercept of a line, let's use that information to graph our equation. This equation is in slope-intercept form, so let's pull out our slope and our y-intercept. The slope of this equation is 2 over 3, and the y-intercept is a positive 5. Now, if you'll remember, slope can also be thought of as rise over run. When we go to graph the equation of the line, we have these two pieces of information. We'll always think that we begin with our b. So we're going to begin with our y-intercept, or where our line crosses the y-axis. We can't start with the slope because the slope just tells us how slanted our line is. We don't know where it needs to go on the graph. So this y-intercept, or where it begins, tells us where we need to start. On our y-axis, we're going to positive 5, which means we need to rise or go up 5 spaces from our origin. We go up 1, 2, 3, 4, 5, and on the y-axis, we're going to put our first dot. Then my slope is rise 2 and run 3 from that point, not back to the origin. We're going to stay on our y-intercept, and we're going to rise 1, 2 spaces, and then run 1, 2, 3 spaces, and put a dot. Now, we rise, or our numerator tells us how much we rise. If our numerator is positive, we're going to go up. If it's negative, we're going to go down. For our denominator, that tells us how to run. So we're going to run left or right. If it's positive, we run to the right. If it's negative, we run to the left. Once we have our points, we can connect our dots, and we can do our slope as many times as we want to help us draw our line. So from our y-intercept, we rose 2 and ran 3. We could do it again, rise 1, 2, and run 1, 2, 3 to help us to get a longer line. And then we connect our points. I'm going to redraw that line because I'm not actually touching that bottom dot. Let me try it again. Okay, and remember, whenever we draw a line, we need to put arrows at the end because this is not a line segment. It's a line and it continues. So put arrows at the end of our line, and that's how we graph a line using slope-intercept form. Let's try another example. Okay, so my y-intercept, or my slope, is 4, and my y-intercept is -1. To get a rise over run whenever I have a whole number like this, remember I can always turn a whole number into a fraction by putting it over 1. 4 over 1 and 4 are the same thing. So we need to graph our line, and remember we need to begin with our b. So we will begin at -1, which means from our origin we need to go down 1 and put a dot. And then my slope, again, it's rise over run, so I'm going to rise 4 spaces from my y-intercept, rise 1, 2, 3, 4, and run 1. And that's where I would put my next point. Like I said, I can do it as many times as I want to. I'm going to do it one more time. I'm going to rise 1, 2, 3, 4, and run 1. And then I connect my points. And remember that we need to put arrows at the ends of our lines. And there is our line. Okay, in this equation, we had our y is equal to -1/2 x. And so when we're finding our slope and our y-intercept, remember, if we don't see any number added after the x, then our y-intercept is 0. So my slope here is a -1/2, and my y-intercept is 0. Okay, so we're going to begin with our b, which means we need to plot our first point at 0, or at the origin. Now, my slope is a -1/2. So when we have a negative slope, we need to put our negative sign either with the numerator or with the denominator, but not both. If I put my negative sign with both my numerator and my denominator, that would be a negative divided by a negative, which would mean that it's positive. So I need to choose either my numerator or my denominator to put my negative sign on, and that would make my slope negative. All right, so if I used negative 1 over positive 2, if I rise a negative 1, that means I go down 1 and then run positive 2, 1, 2. That would be right here. Or if I did positive 1 over negative 2 back to my y-intercept, if I did positive 1, I would go up 1, and then running a negative 2 means I need to go to the left, 1, 2. And you'll, as you see, both of those points are in the same line, so it doesn't matter which one I do, it's going to be the same line. But if I had done negative 1 over negative 2, I would have gone down 1 and to the left 2, and then that would have not been part of the line. That would have been incorrect. Okay, so I'm going to connect my points, put arrows at the ends. And so I want to point something out to you. If you'll remember, when we have a negative slope, that means that our line should be falling from left to right, which is what it's doing here. It's falling from left to right. When we have a positive slope, like we had in the previous example or the previous two examples, our line should be rising from left to right, which is what it's doing in this example where we had a slope of a positive 4 over 1. My line is rising from left to right. So anytime you're graphing a line and your slope is positive, if it's not rising from left to right, you did something wrong. If your slope is negative and it's not falling from left to right, you did something wrong. So that's just a way to double check yourself when you're graphing lines. Now we're going to write the slope-intercept equation of a line given the slope and the y-intercept. So here it says write the slope-intercept equation of a line with a slope of 1 over 5 and a y-intercept of 9. So remember the equation that's our slope-intercept form of an equation of a line is y equals mx plus b. So if they've given us the slope and they've given us the y-intercept, all we have to do is plug it into that equation. So the equation of a line, the slope-intercept equation of a line, with the slope of 1/5 and a y-intercept of -9 would be y equals, remember m stands for the slope, so my slope is 1/5 x, and then plus b, if I plugged in a -9, that would just be -9. And that's how I write the equation of a line given the slope and the y-intercept. Let's try another one like that. Write the slope-intercept equation of a line with a slope of -7 and a y-intercept of 4. So again, y equals mx plus b, y equals m, which is my slope. This time it's -7, x, then plus the y-intercept, and that would be plus 4. And there's my equation of my line. Now let's try writing the slope-intercept equation of a line given the graph. Well, here's the graph of my equation. So I need to find the information that I need in order to plug it into the equation. So remember, for slope-intercept form, we need the slope and the y-intercept. Well, my y-intercept is just where it crosses the y-axis. So you'll see right here, it's crossing the y-axis at a positive 5. So that means that my y-intercept is 5. All right, my slope, I need to look to see where my line is crossing the little crisscrosses of the graph. So it looks like it's crossing right here. If I look, maybe right here. And of course we know it's crossing right here at the y-intercept. So I just need to go from one of these lines to the other, and I'm going to rise over run. So I'm going to travel from this point to this point. If I do rise over run and I stay on the lines and don't go across the ditches, stay on the roads, to go from one point to the other, I rose a positive 2 and I ran a negative 3. So my slope rose positive 2, ran negative 3. That would be the same thing as a negative 2 over 3. All right, so now to write the slope-intercept form of the equation of the line, it would be y equals m, which is negative 2 over 3, x, and then plus my y-intercept, which is b. My y-intercept, which is 5. There we go. Y equals negative 2/3 x plus 5. All right, here's another graph. Let's find the information we need. We need the slope and the y-intercept. Well, let's see. It's crossing the y-intercept at negative 2. It's crossing the y-axis at negative 2. And let's see where it is crossing our crosshairs of our graph. So I just, again, need to go from one point to another. I'm going to go from this one to this one. So I would rise 1, 2, that's positive, and then run, I'm running to the right, so that's a positive 1. So that would be rise 2, run 1, which is 2 over 1, and that would reduce to 2. So my slope-intercept equation would be y equals m, which is 2, x, plus my y-intercept, so plus a negative 2, and that would be the same thing as y is equal to 2x minus 2. Okay, one last example. Let's find the slope and the y-intercept. Well, it's crossing my y-axis at a positive 3, and then we need to find the slope. So I'm going to go from this bottom dot to this top dot, and I would go rise 1, 2, 3, and then run a negative 1, 2. So my slope is 3 over negative 2, or a negative 3 over 2. And to write the equation of a line in slope-intercept form, we would just do y is equal to m, which is our negative 3 over 2x, plus our b, which is 3. And that should be everything you need to know about slope-intercept form. Thank you for watching.